Okay friends, today I am going to discuss about the Bond rule in quantum mechanics, which is used for determining the spin probability, that is the up and down spin probabilities in all the possible directions. Okay, that is x, y and z direction. So let's enter into our today's topic. Okay, it have mathematical expression more, so I will describe by my presentation, and where there would be some physical interpretation or something like that I would discuss over there. So let's begin. Bond rule. Bond rule is used to determine the probabilities of spin in all the direction. What the spin of the particle would be in certain direction, Bond rule is used to describe that. Okay. According to sixth postulate of quantum mechanics, the component of spin in z direction is given as what. According to the sixth postulate of quantum mechanics, uh, what we have known that the component of spin each have two eigenvalues are not plus minus h cut by 2, that have been explained by sixth postulate of quantum mechanics, which I have already discussed in my previous video also. If you become confused, you can watch that video also. So according to sixth postulate, sz, this is the component of spin along z direction. Sz plus minus, this will represent state, plus will represent up state and minus will represent down state, equal to plus minus h cut by 2, then this same as it is. Okay, and this is sixth postulate of quantum mechanics, where gate plus minus represent the spin up and spin down state. Obviously that plus 1 will represent up state and minus 1 will represent down state. Each state is represented by Coulomb vector. In quantum mechanics, we always have to remember that some operator is represented by matrix, square matrix, and then the state is always represented by gate, and that is Coulomb vector. Okay, you have to remember that. So as state is represented by Coulomb vector, so for this up state we will represent by 1 0, and this is down state we represent by 0 1. That is the general representation for up and down state. Always we will use these two state for up and down. Okay, so according to first postulate of quantum mechanics, and as we have already discussed, the first postulate of quantum mechanics is based on the superposition of states or not. So that is the superposition of state. The general solution can be expressed in terms of above state. So the final state, if there would be two possible state, then there would be another state also, which would be linear combination of these two states. So that we have written here, general state is the linear combination of these two states, where alpha and beta are some constant. Okay, is equal to this up, plus will represent up state 1 0 and minus will represent 0 1. So if we put that here, alpha into 1, that would be alpha, and beta into downside 1 1 means beta into 1 beta. So that would be alpha plus 0 plus 0 plus beta, that is alpha beta. Okay, this is the general state. In case of this z component, the component of spin vector along upward direction and this plus gate vector are same. Okay, here we can write arrow upward z also, that will represent the up state spin of component along z direction, and here we can write arrow down z, that will represent the spin down along z direction. In case of z, that would be same. Okay, this plus will represent arrow up z and minus will represent arrow down z. You have to remember that. So our aim is to determine the probability of spin components for that. And we also have to remember that this plus state and minus state are orthonormal set. Okay, as the states plus and minus are orthonormal, the probability of state function in overall space is obtained as. For finding probability, what do we have to do? We have to do psi square, and psi square will give probability. Psi square equal to psi into psi star. So if we do that over here, in the total space, the probability should be how much? Should be 1. So that is equal to 1. And while doing psi star, if we do this into this star, what would be 1 time? Psi, and then while finding its star, what would be? Bra psi star, or not? Bra psi star, and this should be plus bra psi star, bra plus psi star, sorry, alpha star, plus bra minus beta star, and on multiplying that, what do we will get? Plus plus equal to 1 and plus minus equal to 0. So we will get alpha square plus beta square. We will get, we can solve that if we become confused. So on solving that, we will get this alpha square plus beta square equal to 1, where this alpha square will represent the probability of finding the particle along the upward z direction. Okay, alpha square represent the probability of finding the particle in up state along z direction. Likewise, this beta square will represent the probability of finding the particle in downward z direction. Beta square represents the probability of finding the particle in down state along z direction. Okay, that two, one will represent probability along upward z direction, and another will represent probability of finding particle along downward z direction, probability of spin. For that, in simply we will write like this: probability of z along psi, that will be represented by alpha square, and probability of finding particle along downward z direction is represented by this beta square. So now it remains to find the probability of finding particle in up and down state along x and y direction. Now we can directly find the probability of finding the particle in up and down state along z direction by using sixth postulate of quantum mechanics. But according to sixth postulate, we could not find the probability of finding the particle along up and down state along y and x direction. For that, we have to use the characteristic equation. Okay, so after using characteristic equation, we will first find the eigenvalue, and then we will solve that to find the required probability for that. So now it remains to find the probability of finding the particle in up and down state along x and y direction. For that, Bohm used the characteristic equation that was first used by Bohm, so I have mentioned the name of Bohm over here. Okay, what he have done, he have found the characteristic equation determinant for x axis. First of all, he have done for x, and then he have generalized, or he have solved all, but we can generalize, and then we can conclude the result. So at first, determinant of x minus lambda I equal to 0, where this lambda is eigenvalue. Okay, or determinant is represented by absolute sign, so I have right here absolute sign, and x means component of spin along x direction, which is equal to h cut by 2 sigma x according to Pauli Arnott. So I have written that sigma x h cut by 2, but what is the Pauli spin matrix along x axis? I have already found this also in my previous video. If you become confused, you can watch that. What we have found the value of sigma x over there. We have found 0 1 1 0. Alright, so I have put the value of sigma x 0 1 1 0 and h cut by 2 from here, and minus lambda, and I is identity matrix, so here is 2 by 2 matrix, so we put the 2 by 2 identity matrix over here is equal to 0. On simplifying this, what we will get? H cut by 2 into 0 0 minus lambda into 1 minus lambda, and here h cut by 2 into 1 h cut by 2 minus lambda h cut by 2 h cut by 2 minus lambda, right? Minus lambda h cut by 2 h cut by 2 minus lambda equal to 0. That determinant as it is. On finding determinant, what we have to do? We have to multiply this and this, minus this into this, so minus lambda into minus lambda plus lambda square minus h cut by 2 into h cut by 2 h cut by 2 whole square equal to 0. This looks like in the form of a square minus b square. A square minus b square means a plus b, a minus b. From here we can find the value of two values of lambda, are not? So for that two values we represent 1 by plus and 1 by minus. So lambda plus equal to plus h square by 2 and lambda minus equal to minus h square by 2. Okay, now Pauli Bone assumed this positive eigenvalue is represented with up state, and this negative eigenvalue is related with the down state. Okay, and he does further solution. So the state has two eigenvalue, yes, as we have found here. It have two eigenvalue plus h cut by 2, which is related to up spin state, and minus h cut by, which is related to spin down state. Okay, so for up state, Bone assumed up arrow and x, up arrow x, get up arrow x. Okay, this up state have eigenvalue h cut by 2 according to this. This is spin along x direction. Okay, so this is eigenvalue equation. We have put here eigenvalue equation, and in next step we know that the value of sx equal to h cut by 2 sigma x. This is spin along, component of spin along x axis. We have written that in terms of Pauli spin matrix, so this became other as it is, and h cut by 2 can be cancelled because both are the same in both sides, right? So here sigma x arrow up x get is equal to arrow up x get. This is the spin up component of, or state spin up state along x direction, also we can see spin up state along x direction. And Bone assume that this state function would be the superposition of up and down state. Okay, where up state would be equal to 1 0 as we have discussed before, and then spin down state would be represented by 0 1. So Pauli assumed this spin up state along x direction also equals to the linear combination or superposition of that up and down state. So here put the value of arrow of x get vector equal to alpha plus beta minus, where plus equal to 1 0 and minus equal to 0 1. So on solving this, what we will get alpha beta as we have done before. From here, now he put this value in this equation I. Okay, he put the value from second in I. So 1 can be written as this. What we have done, in place of sigma x we have written the Pauli spin matrix along x direction. Sigma x equal to how much? 0 1 1 0, or not? 0 1 1 0 0 1 1 0, and alpha beta that represent state according to Bone is equal to alpha beta. This side also state is represented by this. On solving this, what we will get? 0 into 1 So 0 into alpha 0 plus 1 into beta beta, outside there will be beta, and 1 into alpha alpha, and 0 plus 0 into beta 0. So beta is equal to alpha and alpha equal to beta. So the state can is actually alpha beta. For that we can write alpha alpha is beta equal to alpha. Okay, on substituting this in equation second, we get, what is our equation second? This is arrow of x get equal to alpha beta. So arrow of x get equal to how much? That would be alpha common. We have used initial one. Okay, this we have used. We have used this. From here also alpha, here also alpha. So alpha alpha taken outside common, and plus plus minus, alpha plus plus minus. Likewise, if we put, if we solve for arrow down x from here, what we will get? Here would be minus h squared by 2, so that alpha equal to minus beta and beta equal to minus alpha. So on solving that, arrow down x equal to alpha, in middle there would be minus, other would be same. You can check yourself also how you should check. You carry one time, put here x arrow down x equal to minus h squared by 2 arrow down x put, and then other same h squared by 2 h squared by 2 will cancel. Here you have to put, while putting the, or you have to, here would be minus, so here would be minus minus, and in this equation also here would be minus minus, and here would be minus minus. So alpha equal to minus beta and beta equal to minus alpha. And while putting value in this equation 2, in place of beta you have to put minus alpha. So alpha would be common outside, and plus get plus, sorry, minus minus get, that would be, alpha would be common outside, plus get minus minus get. Okay, if we add this third and fourth, what we can get? We can get the value of this up state and down state. Okay, plus and minus we will get, and then we will normalize these two equations to find the value of alpha, and then we will reach to our destination. For that, okay, let us perform this. On adding third and fourth, what we will get? Here is alpha plus get, alpha plus get, that would be 2 alpha plus get, and this minus 1 and plus term would cancel. So plus get one value we will find, plus get equal to get arrow up x plus get arrow down x divided by 2 alpha, or arrow up x get plus arrow down x get divided by 2 alpha I from here. Likewise, if we subtract this and this, on adding that we will get, and likewise on subtracting this 4 from third, what we will get? Arrow up x get minus arrow down x get equal to, what we will get? 2 alpha get minus. So we will get the value of get minus minus get equal to 1 by 2 alpha arrow up x get minus arrow down x get. Okay, we have found the solution where there is alpha, but we actually don't know the value of alpha over here. For finding its value, we have to do normalization over here. How we can do normalize? We already know for orthonormal set, this plus arrow up x and arrow down x are orthonormal. Okay, since they represent plus and minus, sorry, up and down spin state, so they are orthonormal, two-dimensional Hilbert space, which is orthonormal. So for finding its value, we can do scalar product of arrow of x with itself. On doing that, what we will get? Okay, this again I have repeated the same thing. And to find the value of alpha, we will normalize equation third. Among these two, we can normalize anyone. So I have taken this, and on normalizing this, what I will get? Arrow of x bra arrow of x get equal to 2 alpha square I will get. How that would be? Because complex conjugate, and that should be multiplied. Okay, 2 alpha square, that would be how it would be. This you can check over here. If we take complex conjugate of this, what would be complex conjugate of this equal to alpha star, or not alpha star, and complex conjugate of this would be bra, and its complex conjugate would be, or Hermitian. Okay, its Hermitian is bra. So on multiplying alpha into alpha star, that would be alpha square, and this plus into plus 1 plus minus, that would be, what would be 0. Same one multiplication, that is okay. Get x multiply you can do, so that minus plus equal to 0, plus minus equal to also 0, minus minus equal to 1. So here 1, and another also would be 1. 1 plus 1 2, 2 alpha square, that would be 2 alpha square equal to 1, but we have to find the value of alpha. So this 2 goes downside, become 1 by 2, and square goes to another side, become square root. So square root of 1 divided by square root of 2 square root of 2. From here we found the value of alpha. So if we put the value of alpha over here, then we will find the spin up and spin down state values. Yeah. 1 by root 2, because alpha equal to 1 by root 2, and the root 2 cancel, here would remain 1 by root 2. 1 by root 2, arrow up x get plus arrow down x get. Here also likewise 1 by root 2, arrow up x get minus arrow down x get. At last, for this also, we, according to superposition of state or first postulate of quantum mechanics, we can write psi equal to alpha plus get plus beta minus get. Okay, finally the state of system can be written as uh, psi equal to alpha plus get plus beta minus get. But in place of plus get, what we have found here, we have found arrow up x get plus arrow down x get divided by root 2. In place of plus, I have written that directly. In place of plus get, I have written arrow up x get plus arrow down x get divided by root 2 plus beta, and in place of minus get, I have written arrow up x get minus arrow down x get divided by root 2, which we have found before. Here we have found okay. On simplifying these and bringing this into terms of arrow up x and arrow down x, as we have previously uh, found that the spin up state is represented by arrow up x, and spin down state is represented by arrow x down. So on taking into this form, here would be alpha arrow up x get root 2, and here would be beta arrow up x get divided by root 2. So from here what we will get common, arrow up x root 2 would be common, and alpha plus beta, that is alpha plus beta divided by arrow root 2 and arrow up x get vector, or not. From this first term we have taken this arrow up x get common, and from this later term we can take arrow down x common. So here would be alpha divided by root 2 arrow x down get, and here would be minus beta divided by root 2 arrow x down get. So what would be alpha minus beta divided by root 2 arrow x arrow down x get vector, or not. So what we have found, actually we have converted any general state in terms of uh, spin up state and spin down state along x and x direction, or not. So we can find the probability of finding spin up state along x direction. For that, what we have to do, we have to do arrow x bra arrow of x psi whole square, okay, because that will give component and component square will give probability. This will give the component of arrow of spin state in this total general solution or wave state or wave function, and that will give the component of spin of in wave function, and which square will provide probability of finding particle in spin i- spin of state along x direction, okay. So from here what we will get, alpha plus beta divided by root 2 absolute square, alpha plus beta divided by root 2 absolute square. This is because if there would be complex number, so we have to do star, okay. If there would be a absolute square equal to a star, that's why we have written here this. Likewise, probability of finding particle in spin down state along x direction equals to what, arrow down x and psi scalar product square. So on doing this, what we will get, alpha minus beta divided by root 2 whole square, 1 divided by root 2 alpha minus beta whole square, also we can write whole square, and absolute square we can write, because if that would be complex, we have to do complex into something into complex conjugate, okay. That's why we have to write this term. Likewise, if we solve by taking y component as, here we have started from x component, right? Here we have started from x component, or bone have started from x component. Likewise, uh, he also have started from y component and found the um, probability of spin up and spin down state along y direction also. So on solving in a similar manner, Bone found that the probability of finding spin up state along y direction is, he have found absolute of 1 divided by root 2 alpha minus I beta absolute square, okay. I have directly written this over here. You can solve in a similar manner to check whether this is correct or not. This is the arrow of y, means component of spin along of state of spin up along y direction, and this will represent probability is equal to 1 divided by root 2 alpha minus I beta को absolute square. Likewise, probability of spin down state along y direction equal to 1 divided by root 2 alpha minus I beta absolute square, okay. So from this equation a, b and c, from this equation a is here, this will represent the probability of spin up and down state, probability of spin up and spin down state along z direction, and this equation b will represent the probability of spin up and down state along x direction, and this c will represent probability of spin up and spin down along y direction. So these three equations collectively will gives the probability of finding the state of and spin down direction state in any direction, which is so called Bone rule, right? Okay, at last this equation a, b and c gives the probability of finding the particle in up and down state along z, x and y direction respectively, which completes our today's discussion, okay. Guys, thanks for listening. Don't forget to like, share and subscribe my YouTube channel. This much for today. Okay, bye.